So let's take a look at an example now of configuring redistribution from OSPF into EIGRP. I'm going to enter the command show IP route OSPF. We want to make sure that R3, which is our boundary router, sees the OSPF routes. And in this case, it does. We have an E2 OSPF route for the default route. We have some OIA routes, which are those inter-area routes, routes inside of our OSPF domain but outside of our area. And we have our O routes, the O routes being the routes to destinations inside of our area. So these are the intra-area routes. We're going to use R1 as our verification. R1 is going to be utilized to make sure that we are learning those OSPF routes in this case. So show IP route. And we don't have any external EIGRP routes in this example. So redistribution, not happening yet. Let's go back to R3. On R3, let's enter global configuration mode. Type in router EIGRP 100. It's our autonomous system number. And we'll use redistribute. These are all the routing protocols we can redistribute into EIGRP. In this case, it's OSPF. Process ID we're using is a process ID of 1. And there's the 3 options we have. Notice it says you can hit enter here. All right, done. So I've just specified I want to redistribute all of those OSPF routes that I know about in my routing table into EIGRP. Let's go to R1 for verification. And there's none. There's none. Why is that? Do you remember the default seed metric for EIGRP? It's infinity. So since it's infinity, although redistribution is on, and we are redistributing, all the routes are unreachable. It's infinity. So since they're unreachable, we're not going to redistribute them. We have to specify a metric. So the first value for the metric is bandwidth. So what is the bandwidth going to be? That's a good question. Let me just put 1 here right now. And then the delay in tens of microsecond units. Tens of microsecond units. What's that going to be? Well, let's put a 1 right now. What about the reliability? 255 is 100% reliable. All right, let's just put a 1 there right now. And then load. We have to specify a load. Where 255 is 100% load. Well, that means the link is completely saturated. Let's just put a 1 there for right now. And then the MTU. Although the MTU, if you recall, is not part of the calculation, it's still a parameter that is transmitted and utilized with EIGRP. So they want us to specify that here as well. And then that's it. So where do we get these values from? It's up to you. For example, what I'm showing you right now is a perfectly acceptable value in my topology. It doesn't matter what I put. I could put 1, 1, 1, 1, 1. And then based on those numbers, EIGRP is going to calculate a metric for me. So if this is the only redistribution point in your entire organization, then it doesn't really matter what you put. But remember, the metric is defining the routes. Or the metric is defining how far away that particular network is. So if you want to be more specific, what could you do? Well, if we go over to our topology, what is the exit interface that we're using to dive into that OSPF domain? It's gigabit 3/0. do show interface gigabit 3/0. You could use these values right here if you wanted to. And that would be perfectly acceptable as well. So if we go back to our command, bandwidth is what? Bandwidth was stated in kilobits per second. Kilobits per second. So we could put in 1,000,000 kilobits per second. We could put the delay as tens of microsecond units, or 10 microsecond units. Reliability is 255. Load is 1. And MTU is 1,500. So let's do that. Let's set up our command like that. So metric bandwidth is 1,000,000. And then delay is 10. And then reliability is 255. Load is 1. MTU is 1,500. So that's just another example that you could use. You could use 1, 1, 1, 1, 1 if you want to. Yeah, the metrics are going to be really high. But in our case, it's the only redistribution point in the environment. But if you have multiple redistribution points, now's the time we have to think about that metric. Do you want both redistribution points to have the same metrics? Do you want one to be preferred over another? In that case, you're going to have to manipulate that metric in order to get the desired results you want at those redistribution points. So now let's go back to R1. Let's take a look at the output. Oh, there we go. There's all the externally learned routes. Let's focus on just the 172.16.32.192/29 network. Where is it? Where is it? There it is. So as you can see, we've learned about it. It's an external route. It's learned through the redistribution process. Since it's an external route, it has an administrative distance of 170. Based on those metric values we introduced at the redistribution point, this is the metric. Now, the metric's cumulative. There's no concept of E1 versus E2 with EIGRP like there is with OSPF. So we had that seed metric we defined based on bandwidth, delay, reliability, load, MTU. There was a calculation done based on that, redistributed in, and now R1 sees that as what? An advertised distance, or pardon me, a reported distance from R3. That's going to add its metric to get to R3, and this is what the result is, 5,376. Get there via R3, and we use our exit interface of gigabit Ethernet 2/0. So the redistribution command for EIGRP is definitely simpler. There's not as many options. We don't have to worry about the subnets keyword or E1s versus E2s. It's relatively simple. But what is imperative is you don't forget the metric. You forget the metric, redistribution will not work.